We can look at applying heat to them and using heat to destroy or denature the pathogen. We can look at adding chemical and chemically destroying or deactivating that pathogen. Much the same way as you would think about, how do I clean my kitchen? Do I use boiling water on something? Do I use soap? Do I use vinegar? These are different combinations of using heat and chemicals to destroy or deactivate pathogens.
What I want to talk about here is just the evolution of technologies for dealing with biological and medical waste. Like, how has the disposal of life sciences and medical waste evolved over the past 50, 60 years or so?
So from the time that medical waste is created in a hospital, in a clinic, in any other medical setting, to the time it's fully treated and disposed of, it's the generator's responsibility. And all of that really emerged in the late 80s into the early 90s, kind of as a result of these well-publicized concerns around used medical devices washing up in public areas. And from the 2000s and only accelerating today is just the significant increase in the amount of medical waste being generated. We live at an incredibly fortunate time to be alive. We have treatments for diseases that we didn't even know the disease existed 50 years ago, let alone have a treatment available for it. But when you think about a lot of these longer term treatments, every step of that process creates more waste. And that waste has to be treated to the highest standards to make sure that as populations grow and become more dense, we're not acting as a vector for the spread of disease. There's a number of different treatment options and technologies that have kind of emerged from the 80s to now, and they're all looking at the best way of coping with rapidly increasing amounts of medical waste. We're trying to make sure that any bacteria, viruses, fungi, or other pathogens that are present in that waste are destroyed or deactivated. We can look at applying heat to them and using heat to destroy or denature the pathogen. We can look at adding chemical and chemically destroying or deactivating that pathogen. Much the same way as you would think about, how do I clean my kitchen? Do I use boiling water on something? Do I use soap? Do I use vinegar? These are different combinations of using heat and chemicals to destroy or deactivate pathogens. Stepping away from incineration, we start looking at, okay, what are lower temperature, non-burn methods for deactivating pathogens using heat? So if we look at introducing steam or heat, we're looking at autoclaves, where you use a high pressure steam boiler, hold a vacuum, and inject high pressure steam into a vessel with the waste inside of it, trying to bring the temperature of that entire waste up to usually about 212 C, and hold it there for about 30 minutes when you can confidently say you've deactivated everything in that waste stream. Now, an important piece to think about when we're looking at both heat and chemical treatments is you're only able to disinfect or destroy pathogens on surfaces that you're exposing either to that increased heat or to those chemicals. And that's part of the issue we arrive at when we look at treating medical waste. It often comes bundled in bags. You're not allowed to open the bags prior to treating it. You may have a lot of insulating material, gauzes, linens, sheets, wrapped around vessels containing liquid, roller bottles, IV bags. And in that situation, how are you ensuring that the entire waste stream is either being heated to your desired temperature for the amount of time or being fully exposed to chemicals? And that's where we start looking at shredding or grinding as a tool to use in conjunction with either heat or chemical to maximize the surface area and make sure that we're fully exposing all of the waste that needs to be treated, either to the heat source that we're using to raise the temperature or to the chemical that we're using to chemically disinfect. Conceptually, it makes a ton of sense. So that's really where I've seen the biggest evolution in autoclaves over the last few years, is looking to integrate more of that shredding or grinding functionality into their process.
Now sustainability leaders are becoming more prevalent. It's become more of a focus, not only from the regulatory point, but also from a publicity standpoint. And this is where BioSAFE is leading the parade of companies that are sincere or really focused on seeking or implementing sustainable, lower carbon footprint waste treatment systems are ways to lower their carbon footprint. I think we're one of the most curious companies, many questions. Each piece of equipment, even whether it's standard or non-standard equipment, is like a snowflake. We'll tailor that product to their particular needs, whether it's solid or liquid waste, and begin a path to reach those goals. So we evaluate and work with and for companies, not doing something to them, and offer the most eco-friendly solution for any particular waste stream. As we talked about before, non-burn, eco-friendly, bulk reduction, landfill diversion is our goal. So it's really exciting to see where sustainability is more of a focus, a low carbon footprint. This is language has now found its way within many companies and fits within what BioSAFE can provide for them.